Hello, and thank you for joining us on episode 249 of the Space Nuts podcast. I'm your host, Andrew Dunkley. I didn't want the job, it just got thrown at me, but here I am. Yes, I did want the job. And my partner in crime here on Space Nuts is, of course, astronomer at large, Professor Fred Watson. Hello, Fred.
Morning, Andrew. How are you doing?
I'm well, thank you. It's good to talk to you. And we've got a lot to celebrate today because we have cracked 1 million downloads as of last week. Since January of last year, 1 million downloads of the podcast on our current platform. And then we went back and thought, well, I wonder how many were before that. And so it does actually look like we've certainly surpassed 2 million downloads since we started, which is just extraordinary. So a big thank you to everybody who has, downloaded once or 1 million times. I don't, whatever. We appreciate your support, our listeners in general, our patrons, for putting a few bucks in here and there. It's just fabulous, and I never thought I'd see the day where I could boast 1 million downloads of the podcast.
Of anything.
Yes, indeed. And Hugh back in the studio tells me that puts us right up into the higher rankings of podcasts globally, and with the numbers we've recorded in the last few years, we're probably one of the top 1% podcasts, which I think is just an extraordinary achievement. I'm totally dumbfounded that two old farts like us are getting that much attention. It's it's terrific. So thank you to one and all for supporting Space Nuts, and onward and upward. We will show ingenuity in the future. In fact, we're going to talk about that shortly. We're also going to talk about the square kilometre array because our government, the Australian government's chucking in a couple of dollars. And when I say a couple of dollars, I'm being literal. No, I'm not. I'm just stirring the pot. And some bad news for those of us who were looking forward to jumping on the USS Enterprise and going to Warp Factor 1. Never going to happen. New research has kiboshed the whole thing. And we've got questions from Rusty and Donnybrook and Dealer from Toronto. And one more thing I need to add before we get started, Fred. Apologies in advance if you hear weird noises coming from my end of the spectrum. I've got landscapers here today doing a bit of work out the back, and they may be cutting pavers at some stage. They're wheelbarrowing them in the yard. I told them I was busy, I couldn't help. But yeah, they're wheelbarrowing from the front yard out of the truck to the backyard where they're putting the pavers down. We're getting a little barbecue area done. And the upper plateau of my yard, which has been a useless piece of land for a long time, I'm very excited. It's going to be a putting green. Talk about self-indulgence. I'll send you a picture.
Right.
I know it's not space worthy, but I'll do it anyway. So there we have it. So if there's some noise in the background, just ignore it. They're not here. But first, Ingenuity, success at last. I tried to stay up and watch it, but the thing about NASA, no disrespect, is if something's at 9 o'clock, it's 12 o'clock. So I just couldn't hang in, but I made sure I looked at it the next morning. Fantastic and a great success to get it off the ground, do a little bit of a hover, a pirouette and a landing. It was just all over and done in less than a minute, but it might have taken no time at all, but it was one of the great achievements in human flight history, I think.
I absolutely agree with you, Andrew. It was. It's a Wright brothers moment. And of course, the Ingenuity helicopter carries a little bit of fabric from the Wright brothers' first aeroplane, isn't that?
We keep this up. There's not going to be much left of the plane. That's the part that worries me.
That's right. Well, I've got it.
Have you?
I'm sure everybody has. No. But it will be lovely. This the first step in aviation on another planet. The next step will be another flight, which is a little bit more ambitious because they'll rise a little bit higher, I think 3 meters or so, maybe a bit more, but also move forwards and backwards 15 meters. And I think there are 2 flights like that, just to check out that the aerial vehicle can move as the mission controllers want it to. And then the last of the 5, there are 2 flights left because it's a suite of 5 flights that they're planning. They will go far and wide. We don't know what they have in mind, but I'm sure we'll see some amazing images coming back from the surface of Mars. The one that I was most impressed with, there was a little movie that Perseverance itself took of the flight. Perseverance was 65 metres away, just to make sure, if things really went ballistic, the helicopter didn't clout the cameras or something like that. But there's a nice shot, only in black and white, as I'm seeing it at the moment, taken by the helicopter itself, looking down at its own shadow.
Saw that one, yes.
Yeah, it's great. It's fantastic stuff.
Yeah.
And actually, you can see not just the shadow, but you can see the tyre tracks of Perseverance as well on the same shot.
Yeah.
So fantastic stuff, and we believe that perhaps maybe even when we speak next week, there might be more to report.
Indeed.
On what's happening with the Ingenuity helicopter.
The test I'm looking forward to, Fred, is towards the end of the mission when Perseverance unveils its Martian cannon and Ingenuity rises. But on a more serious note, and this is going to be a question without notice, but we did get a question, I think, via Facebook from somebody asking, in the test phases of Ingenuity on the ground, they had to try and replicate the conditions that they would face on Mars because of the completely different environment and the very, very thin atmosphere, less than 1% of Earth, etc., etc. How did they replicate the gravity situation? Did they do it with computer modelling? What was the go?
So the question was from I've got it in front of me actually, from Judd Brown in Sydney. Hi, Judd. So Judd's question is: yes, you can clearly compensate for the lack of pressure. You just put the thing in something like a vacuum with only 1% of the Earth's atmospheric pressure, but the gravity is harder to simulate. And so what Judd suggests is, do they come up with an atmosphere somewhere in the middle between Earth's and Mars? And I'm sure that is one of the tests that they did. They would have tested probably, with Mars atmospheric pressure and Earth gravity, because that's giving them a really tough gig. They've got 3 times the gravity they're going to experience on Mars, and the atmospheric pressure they have on Mars. So I would guess they did that as a check to see where it, how it performed under those really arduous conditions. Engineers always design things to withstand 2 or 3 times the stresses that they're supposed to, and that would be the way they do that. But I think Judd's suggestion of putting an atmospheric pressure somewhere in the middle between Earth and Mars, that would also be a test that would be done as well. So anyway, the bottom line is that the test all worked, and so did the helicopter.
It did.
So
they got it right, and can't wait for what happens next. So fantastic. And thanks for the question, Judd, because I did want to throw that in when we talked about Ingenuity, and I remembered at the last second, which is one of my terrible habits.
It's a good trait. It's better than forgetting at the last second, which is what I do. And I did forget, in talking about Ingenuity, to mention that those transmissions that were received from the first flight actually came through Australia. They came through the Tidbinbilla Deep Space Tracking Station in Canberra, where our good friend Glenn Nagel was certainly talking about it quite a bit on the radio.
That's lucky, because they only got electricity connected last week, so it's a good thing.
Bad times.
Okay.
Anyway,
there'll be much more to talk about in the future, in the very short future, regarding Perseverance and Ingenuity on Mars. It's all happening. All systems go at the moment. Right. Let's move on to the Square Kilometre Array. We've talked about this many times, but we haven't really talked about the money. But we are going to now, because the Australian government's chipping in a mere $387 million. That's Australian, so in US dollars, that's $3.
It's a little bit more than that, but that's real money. I mean, it's this is an announcement that was made last week. I have to say that my colleagues, people I work with and amongst in the Department of Industry, Science, Energy and Resources, who put together the budget considerations and things, they were working flat out on this for the past few weeks, and certainly last week. they were getting it all tidied up, and then the announcement was made on Wednesday, which is great. So what this signifies is the Australian government's ongoing support for the Square Kilometre Array project, which our listeners, I'm sure, will remember is 2 telescopes, an array of telescopes, 160,000 of them is the number. Am I getting that right? I think so. No, 131,072 antennas, which look like Christmas trees in Australia. That's the low frequency array. The mid frequency array is going to be in South Africa, where they have something like 60 dishes, which look at the slightly higher frequency range. So a two-pronged attack on the universe to build the world's biggest telescope, and as I said, this signals Australia's ongoing support for it. Of course, governments always have to put the positive spin on things like jobs and growth.
Yep.
Those are the mantras of governments all over the world. And indeed, this is really, there's big numbers involved there too. There are something like 350 new jobs being created during the construction period, 10-year construction period. And then over the 50-year life of the project, because this is going to outlast you and
yes.
me, Andrew, there'll be 230 ongoing positions. This is serious stuff. These are big numbers for the jobs that this gigantic project will build. And just to mention as well that two things. One is that it's not just Australia in this. There are, I think, 16 nations are now signed up for it, 16 member countries. All over the world. Actually, I might just list them because it's quite an interesting bunch. Australia, Canada, China, France, Germany, India, Italy, Japan, Korea, the Netherlands, Portugal, South Africa, Spain, Sweden, Switzerland, and the United Kingdom.
Wow.
Are in there. You might notice one country that isn't in there is the United States, because their interests in radio astronomy don't really align with what the SKA member countries are doing. So it's not, it's not taking your bat and going home or anything. It's just a natural thing about the scientific endeavours of these countries. But to anybody who's listening to us in one of those listed countries, well done. Your country is part and parcel of the SKA community. And what I was going to say is that that investment that the Australian government has put in, it means that what you're doing is you're stimulating foreign income flows into Australia because of that. And certainly in the first 30 years of operations, they estimate 1.8 billion in foreign income will come into Australia. So very important stuff. And one final thing to mention is that there is a chunk of that budget, 64.4 million, in establishing a specialist supercomputing centre, which will be in Perth, Western Australia, to do all the thing about the SKA is it generates 10 times the current, or it will generate 10 times the current internet traffic on the whole of the internet.
Wow.
And they'll do that 10 times over. So you need these enormous computing centres to do that. It's very exciting stuff. I'm delighted we could get a chance to talk about it. And well done, Australia. That's that's me waving my flag for the country that is close to my heart, closest to my heart.
I thought that 64.4 million was going into the Fred Watson Retirement Fund, but I clearly was misinformed. But one thing about this, and I don't want to sort of overshadow it with politics, but the politicians are the ones that sort of fly the flag and get the accolades. But you got to give credit to the people that work in those back rooms in Canberra, in the Treasury Department and the budgeting people that sort of figure all this out and work out, we can afford to do this over this period of time through this avenue of funding. And they work so hard and they never get thanked. So thank you to the invisible people in Canberra that do all the pen pushing, that make all this stuff happen, because you deserve to be recognised.
Look, I'll be talking to them in a teleconference this afternoon, Andrew. I'll pass on your message. Yeah,
I appreciate you, being an administrative person myself. I've done a lot of administration in my life.
Yeah, me too, in my time.
I find it therapeutic. I do, honestly. But no, it's good news. It's really good news. And I suppose we should, just for the sake of it, refresh people's memories as to what the SKA's role is going to be. What are we trying to achieve with it?
So it's remarkable. Its remit is the entire history of the universe, basically, because it's, the kinds of things it will be looking at are the Dark Ages, that time between the Big Bang and the first star switching on, when the universe had a lot of cold hydrogen in it, which the SKA will be able to not only detect, but to map it out, to see where it lay and how that formed the universe's growth. And then things like the origin of magnetic fields in the universe. That's one of the key targets of the SKA. One that I am very interested in and very keen on is that SKA will detect very large numbers of pulsars. These are neutron stars, spinning neutron stars, that essentially let us test gravity at very extreme levels. Neutron stars and black holes are the most gravitationally strong objects that we can see. And so what you're really interested in is looking at these objects in detail to see whether relativity still works at these high gravitational intensity levels, because relativity is our best theory of stuff in the universe, but we know it's got holes in it. We know it doesn't completely work. So that is, this is one of the things that in fact, I had in mind when about 2 years ago I went before a committee, a high-level political committee, which was ratifying the treaty that the Square Kilometre Array, the international treaty that it's going to be built under. And I promised them Nobel Prizes, which might have been... I said they had my personal guarantee that this would generate Nobel Prizes, and that actually appeared in Hansard. But
it's on record.
So it was not entirely a throwaway comment. Of course, at my age, I can promise anything, Andrew. But it's not a throwaway comment, because I believe that if the SKA reveals insights into the absolute fabric of reality that underpins all of relativity and quantum theory and everything, and it may well do, that will certainly generate Nobel Prizes.
Yes, indeed.
So all of the above, plus just finally, coming right up to date. The SKA can detect an airport radar at 50 light years, so who knows what we might pick up going on in our neighbourhood in the universe.
Indeed, yeah.
In terms of intelligent species.
Well, fingers crossed. We can be hopeful. Indeed. All right. You're listening to, and if you're on YouTube, watching the Space Nuts podcast, episode 249. Andrew Dunkley here with Fred Watson.